everybody, welcome back boys and girls. It's your main math man, Mr. Jen, coming to you live from Summon Academy. In this video, working still on our unit number 5, talking about our functions. We're on lesson 7 now. So we're coming towards the end of our functions, but we're still talking about independent variables, dependent variables. We're working with functions, whether it's an equation, a graph, or a table. And we're going to be talking about also how we can apply this to volume, area, and how those formulas work out. So in the first part it says which are the same and which are different. Here are 3 different ways of representing functions. Again, you have a equation in the first one, a graph in the second one, and in the third one it's going to be a table. And it says how are they alike and how are they different. And so for the first part we can say they are all alike because they represent linear functions. So I know this because for the first one, my degree or power of x is equal to 1. So as long as it's equal to 1, I know that's going to be a linear function. Then I can say my graph is a linear function because it's a straight line. And then for my table, I know it's a linear function because it is a constant rate of change. Meaning, if I look at my y values, they're each time or each step, it is decreasing. Try that again. Is decreasing by 2 for every 1 step I move on the x-axis. It goes down 2 steps on the y. So these are just some examples of how I know those are linear functions. So whether it's an equation, graph, or table, I should be able to tell whether it's a linear function or not a linear function. And then I could say they are all different because they all have different variables. If I look at the first one, this has y and x. My second one has a and b. So this is x and y. And my other one, or my table, has p and q. So even though they have different variables, I can still kind of say that they all are linear functions. Alright, on the second part it says the graph shows the temperature between noon and midnight in city A on a certain day. So let's label that, let's label this city A, and our table, this table is going to be city B. And so it says the table shows the temperature T in degrees Fahrenheit for H hours after noon in city B. So this one goes from 1 to 6, where this one goes from noon to 12, midnight. So the first one, it says which city is warmer at 4 p.m. So let's find out. Let's find where 4 p.m. is. So in our table, real easy to find. 4 p.m. it is 62 degrees in city B, and 4 p.m. on our graph is going to be that point right there. So we're going to say for this one it's going to be, let's do it in red still, let's say city B is warmer at 4 p.m. Because if we look or compare, we're saying 57 or just over 57 degrees for city A versus 62 degrees for city B. Then for number 2, it says which city had a bigger change in temperature between 1 p.m. and 5 p.m. So let's talk about what does city A have. So we have from 1 p.m. So it was about 50. So let's say for A, it was 50.5 to, let's find out where it ends, 4 p.m. about 58, or sorry, 5 p.m. 5 p.m. is about 58, there we go. And for city B, we can say, and city B is going to be what? Well, from 1 p.m. it was 82 degrees, and it went to 5 p.m., which was 58. So for that one as well, that had a bigger change because this was only 7.5 degrees, where this was 24 degrees. So we're going to say that city B for this one as well. So city B. You can make sure you can circle or box in your answer, that way you know which is which. Okay. And for number 3, it says how much greater was the highest recorded temperature in city B than the highest recorded temperature in city A during this time. So we have to find it for city A. Let's find it on our graph. So let's say, do in blue again, the highest temperature. So that's going to be easy to find because we just look at a graph and say, well, the highest point is about right there. Let me try that again. About right there, which is about 59 degrees. 59 degrees. And city B, again, compare these numbers. We're going to say 82 is actually going to be the highest. So city B is going to be 82 degrees. And so what's the difference between these two? Well, we can take 82 minus 59 to get 23 degrees. So that's going to be the difference between the highest for each city. And then for number 4, it says compare the outputs of the functions when the input is 3. So that's real simple to do because all we have to do is we have to look at when the x is 3, meaning the input. So we're going to, let me get rid of these points. So I find and say, okay, well, table, real easy to find. When h is 3, the output is 75. And then when h is 3 on here, the output is about 54.5. So let's say for city A, let's have the point 3 comma 54.5 degrees. So when the input is 3, the output is 54.5. And for city B, we said the ordered pair is 3 comma 75. Let's compare those two by taking the difference. So we're going to say B is hotter than A. We can say by 20.5 degrees. So be able to, switch between the table and the graph and be able to say, again, your x-axis is your inputs. So x is inputs and y is outputs. Just remember that when you're looking at the tables and the graphs. All right, towards the bottom it says comparing volumes. It says the volume V of a cube with edge length s centimeters is given by the equation V equals s to the third power. And then it says the volume of a sphere is a function of its radius in centimeters, and the graph of its relationship is shown here. So it gives you the graph. This is also on on lesson page. If you want to play around the graph, that way you can find those values. It's a little bit easier to see, but it looks like this. And so we're going to say, for the first part, it says, is the volume of a cube with edge length s equals 3 greater than or less than the volume of a sphere with radius 3? So for our volume, I can write it like this. For the first one, I'm going to say volume equals, we're going to say 3 to the third power. And again, be careful, it's not 3 times 3. It has to be multiplied out. So we're going to say 3 times 3 times 3. So we're saying this is going to be 27 centimeters cubed. So that's going to be the volume of a cube. And then for our, let's do orange, our volume for the sphere, there we go, volume of a sphere, let's find where that is at. Well, so find on your x-axis, again, we're looking at radius. So we're going to say, all right, when radius is 3, that's going to be about right here. And so that point is going to be, so we're going to say the volume of that one is going to be equal to, let's say, about 113 centimeters centimeters cubed. Again, you can find that by either typing it into your Desmos calculator or being able to look on the graph. We can say that, hey, this one is going to be, the cube is going to be less than the sphere. So we're going to say our answer is going to be less than because the sphere has a greater volume. Then for number 2, it says if a sphere has the same volume as a cube with edge length 5, estimate the radius of the sphere. So this one's a little trickier, but we can set it up like this. We're going to say, okay, for that first one, if the edge length is 5, so we're going to say volume equals 5 to the third power, which is 125 centimeters cubed. So now what we have to do is we have to find, well, on our graph, if we look for our volume, so it says the same volume, we have 125, which is about right here. So we're going to follow this line. So this is going to be about 1, 2, 5. Follow that out, see where it hits the line, and we could say, well, it's not 3.25. It's going to be about 3.1. So we're going to say the radius for this sphere, radius is going to be equal to about 3.1. Again, we go from the same volume, we use that on the y-axis this time because we have our volume on our y-axis. Then we have to find what the x-axis is going to be, which is our radius. And for number 3, it's to compare the outputs of the two volumes functions when the inputs are 2. So this is real simple because we're going to say volume equals, we're going to say 2 to the third power, which is going to be 8 centimeters cubed. And then we're going to say find on our x-axis we have 2, so we're going to have this point about right here because our radius is 2. And so it's going to be about, the volume of the sphere is going to be about 35 centimeters cubed. So we're going to say that volume of the sphere is, let's say, take the difference, 27 centimeter cubed larger. There we go. Or you could say more. Either one works. Moving to the back. For number 1 on our practice problems, it says the equation and the table represent two different functions. It says use the equation b equals 4a minus 5 in the table to answer your equations, or your questions, I should say. This table represents c as a function of a. So we're going to say a is going to be our independent variable. That's what we plug into our function, where b and c are going to be the dependent variables. So we got two different functions here. And the first part, or the first question, says when a is -3, is b or c greater? So we could find out. Let's compare what we have. Let's do pink and gray for this one. Let's say for b, let's find out. So we're saying we replace -3 in our function. So we're going to say b equals 4 times -3 minus 5. This is going to be -12 minus 5, which is -17. And if we look at our other function, let's actually do purple. Yeah, let's do purple. For our other function, for c, again, when a is -3, so that's going to be this point right here. So which one is greater? Well, we're going to say that even though they're both negative numbers, we're going to say that this function b, we're going to say b is greater than, let me try rewriting that real quick, is greater than c when a equals -3. And we get that from comparing -17 and -20. For the second one, it says when c is 21, when C is 21. What is the value of A? Well, we can find that by circling it right here. So C is 21. That means our value of A is going to be 5. And it says, what is the value of B when we have A equals 5? So we plug that in. Let's do right here. We have 4 times 5 minus 5. Well, 4 times 5 is 20. Minus 5 is going to be equal to 15. So when A is 5, we would say B is 21 and, or sorry, C is 21 and B is 15. Then it says for the third one, when A is 6, which one is greater, B or C? Well, we actually can't compare that one because if we look, we're going to have to say this. We're going to say, for this third one, we're saying not enough information. The reason why that comes up is because there's not enough info, since the table does not have A equals 6. So since it's not in the table, I could probably try to come up with the equation, but there's no real pattern to it, so we won't be able to find it. So even though we can solve it for our value or our function B, we wouldn't be able to find it for our table C. And then for the last one, it says, what values of A do we know that C is greater than B? So let's highlight this. So we're going to say that we know, or let me actually write this out. We're going to say when A equals 0, 5, and 12, we can say C is greater than B. Again, we can check and plug those in. We would say 4 times 0 is 0, minus 5 is negative 5. So when B is negative 5, C is 0, or sorry, C is 7. So that's going to be different. When we have A is 5, our function B was 15 and this was 21. And then when this is 12, 12 times 4 is 48. Minus 5 is 43, which is still less than 45. Alrighty. Moving on to the second part, it says match each function rule with the value that could not be a possible input for that function. And so what I want to start with is remember that dividing by 0 gives an undefined value. So for right now, we're not going to divide by 0 because we're not able to. And that's what it actually talks about. So it says we're looking for the ones that are not possible inputs. So it says 3 divided by that input, well, that's going to be 0. So that one crosses out. Add 4 to the input, then divide this value into 3. So we're going to say this is going to be negative 4, because if you have 4 plus a negative 4, it's going to be 0, and it can't divide by 0. And then lastly, it says subtract 3 from this input, and then divide that value into 1. So 3 minus 3 is going to be 0. 1 divided by 0 is an undefined number. So for each of those, just make sure you can't do that because it's undefined value. For the third part, it says Elena and Lynn are training for a race. Elena runs her mile at a constant speed of 7.5 miles per hour. And if you actually take and try to solve that, what you can do is well, there's 60 minutes for every 1 hour. And so what you could do is you could say 60 divided by 7.5 gives you 8. And so we're going to say 8-minute mile. That's going to be Elena's pace. So Lynn times are recorded for every minute in that table given. So it says who finished their mile first. And so, well, we would say, well, if we look, Elena had, which I need to write down, but Elena had an 8-minute mile where Lynn had a 9-minute mile. So we're going to actually say that Elena finished first because since 8 is faster, and the keyword there, usually we were looking for that larger number, but we're going to say that it's going to be faster than Lynn's 9-minute mile. And it says for part B, it says this is a graph of Lynn's progress. So it should be, these table values plotted on a graph. It says we need to draw a graph to represent the Elena's mile on the same axes. So what we're going to do is real simple, be able to plot out 2 points. Again, we know after 0 minutes we go 0 distance, so that's going to be our 1 point. And then our other point we need is at 8. At 8 we had our finish time, so we're going to say at our distance in miles was 1. So since we have our 2 points, we can graph our line. And so I'm going to connect those 2 points, real simple. And since they stop after 1 mile, we don't have to keep going. So we can draw a graph, something like that. That makes sense because, it's a straight line because it is constant speed. And it's going to be faster, which is why it's just slightly higher on the graph. Then for part C, it says for these models, is distance a function of time? And then it says, is time a function of distance? And explain how you know. So we can say this, we're going to say, in both models, distance is a function of time, and time is also a function of distance. And this works out because we can, switch them back and forth. So that means this. It says, given a time for either runner, the distance can be found, and vice versa. And when it says vice versa, it says this. We can say, given a distance for either runner, we can find the time. So be able to, switch back and forth. Are these going to work out? We would say yes, because we don't have, any repeated x or y values. And then for the last one, it says find a value of x that makes the equation true. Solve by graphing. And so make sure, again, remember when you go to graph it out, let's highlight our one side. So we're going to say, here's one equation. This is one equation. And then we're going to say, here's another equation. So you're going to have 2 different lines. So second equation. So when you have 2 different lines, make sure you can graph those out. Find that solution point. Let me say solution point. Again, is an x and a y value. Find where they cross. Again, make sure you can pause for your turn, graph on Desmos, and check with me. Otherwise, be able to rewind, replay, ask questions as they come up. And as always, super slam that subscribe button.